Alright, so for this section, this is what we call analysis of variance. Analysis. Analysis of variance. It looks weird because I never write it out. Another way of writing that is call it by its official, what's the word I'm looking for? I don't want to say acrostic, by its acronym, Anova. And so, Anova is what we will be doing, analysis of variance. Okay? Now you're like, what does that mean, Jay? Well, it means this. So, back in chapter 9, we discussed the differences in averages or means between two samples, right? So, is there a difference in IQs between men and women? Is there a difference in, I don't know, how much food an elephant can eat, the average elephant can eat versus the average giraffe, or whatever, okay? And so for two populations, the two sampled Z's or two sampled T's are swell. But what if you had more populations? What if you had, no, I don't know, the Albertsons versus your Whole Foods versus your, I want to say Safeway, but a Safeway and Albertsons says, oh, versus your Winco. Nice. And average grocery bills or whatever. Okay, and so you go out and poll some people. How much did you spend? $30, $25, $26, $50, $57. For the same basic baskets of goods or something. I don't know. Okay, we can get in more. We'll get into more of that later on. What am I saying? Is there a difference in the price of these stores, the average price, or what have you? Okay, and so here I am taking a very scientific survey, of course, because that's what I do. Basically pulling these numbers out of the magic Pez dispenser. And so here they are. Now, clearly you could do a t-test between these two, or a t-test between these two, or a t-test between these two. But with analysis of variance, what we're going to do instead is this. We're going to test them all at the same time. And so we're going to say this. Our H naught is there is no difference in price due to the store in question, right? And then, of course, H1 is, well, at least one, it'll always be this, at least one is significantly different. Now, this is a two-tailed test. Okay? So when we say significantly different, we literally mean significantly different. We don't mean greater or smaller or anything. We just mean flat out different. Now, I'm going to use just Excel for these, and I want you to do that as well. Now, so I will do it in Excel. First thing is I want you to do this. I want everyone to do this in Excel with me. Okay, so if you don't have Excel, I will show you. There's a couple things we can work on. Well, if you have Excel but you don't have the data analysis tool pack, I'll show you another way around that. So first of all, data, and I want data analysis. Again, if it's not there, under the File tab, under Options, Add-ins, Go, you want the top one turned on. That's what will get it there. If that's still not there, under, I think it's under Insert, no, where is that? Pay attention, it's been a while. I looked at this. I don't have to do this, that's why it always gets out of my way after a while. I forget where it's at. Yes, well, it's here somewhere. Where'd it go? Okay, so this version doesn't have it. Some versions will say, it'll say there'll be like a little app store thing right here. It'll say get. You can go and get that. And so I'll show you that later on how to do this. So I'm going to show you how to do it first, and then I'll show you also what this other tool looks like. The other tool, I actually use it a lot in Google Sheets. For I have a class that I teach that I do some stuff with Google Sheets on, specifically because it's easier for what I do with it, and so it's kind of neat that way. Alright, so I've added my data. Okay, and this is how we're going to do this. Okay, what we're going to do is we're going to take this data and we're going to use this data analysis business. And we're going to come up here to the top and we're going to do an Anova single factor. Because the only thing that's changing here is what store I went to. It's the only difference. Okay? Now, my input range is everybody. And then make sure you click on labels in the first row. Okay? Now this alpha is not terribly important. I'm going to show you where that comes into play later, but if you have one that was 0.1, for instance, you could put it in there. It's neither here nor there because the chart we get in just a minute is going to have a p-value on it. And that's all I really want to focus on is that p-value. Okay? And so I'm going to put my output right here next to my data. I like that better. Otherwise it opens a new tab for me and I don't like it. This right here is what is called an Anova table. I'm going to go ahead and make this bigger so we can see them all, and that's lovely. Your eyes should focus right here, right now, every single time, without fail. Look at that p-value. Holy cow! That is less than our what? Our 0.05 or 0.1 or whatever. Okay. It's always less than any p-value will ever than any alpha I would ever ask you. Now you're like, what was that 0.05 about? It gave me this critical value, okay? And we're testing this guy relative to him. Hey, that's an F test. I know, right? What we're doing on this F test is we're taking this value here as our numerator, divided by this guy here as our denominator, with 2 degrees of freedom and 12 degrees of freedom. That's how we're finding that F statistic. That's how we're finding that p-value. Okay, so be aware of that. That's how we're getting this number. That's where it's coming from. But suffice it to say, there's our value. So come back over here. What does that mean? It means you're going to reject H naught. Well, wait a minute. If I'm rejecting H naught, reject H naught, what does that mean? It means at least one is significantly different. Well, inquiring minds would like to know, which one is it? You know, is it that Winco is that much cheaper? Is it that Whole Foods is that much more expensive? Or what? Because I actually want to base a decision on this goofy thing. That's what I want to know. Okay? So what I'm going to have you do for the homework, or not for the homework, but for the come test time. So your homework, it's up here on the screen. Okay? The homework will all be in that connected math business, so it's not a big deal. You'll just look at the p-value and answer the question. Okay, and then you'll do a follow-up. In a minute, I'm going to show you how to do the follow-up. And we're going to go from there. Now, that said, this, again, it's not very difficult. That literally took 2 seconds to get this data information. Okay, so that's not the tricky part or the hard part at all. Now, the follow-up is going to be a little more interesting. But before we go on to that, what I want to talk about is this. This variation, the change that you see, is of 2 kinds. So the first kind is what we call between groups, or that's because. Oops, well, sorry, I wanted to make that all one big. So this between groups one is because of the different, in this case, store, right? So the only difference is because it changed stores. Okay. Now, obviously, within stores, there's also variation. So this is inside of each store. This also is called error. Okay. It is that idea that not just because everybody had the same thing done to them, you shopped at the same store, you bought the same sort of stuff, whatever, doesn't mean you spent all the same money on it. Okay. Another place where this shows up frequently is the idea of different kinds of fertilizer. I use the same kind of fertilizer as the neighbor, but he has a nicer looking lawn. Why? I don't know. Maybe he had some other topsoil hauled in. Maybe he just slightly better yard quality stuff than I do. Maybe I have too much shade. Okay, so there's going to be variations, you see, within these things. A similar deal is if you give uh, same kind of acne medicine to two different people, or like 10 different people, you're going to have the 7 or 8 people kind of respond similarly, and then you got a couple of weirdos that are kind of different, like their acne didn't get worse, or it didn't get better and it didn't really heal up or whatever. And people that like totally cleared up right away. There's always going to be that variation, we say, that difference between them. Okay? Now, how do we do these follow-up tests, right? We got to know, how do we follow it up? Well, there's two kinds of tests. First one is what's called okay, that's not true. There's two that your books show you how to do. Okay? So we're going to stick with those two. Okay? But off the top of my head, I can think of 5 different kinds. But the two that your book uses are the Tukey test and the Scheffé test. Nice. And the Tukey test we used on balanced Anovas. Now, what do you mean by a balanced Anova, Jay? Well, what I mean by that is this one here that we just did is balanced. That is, there's the same number in each column. An unbalanced one, obviously one of them has a different number. So the Scheffé can be used for balanced or unbalanced. It's funny because some books I've taught out of in the past don't teach either one of these two, although you could just do just Scheffé if you wanted to. Other books that I've taught of in the past, they only teach, like for instance, the Bonferroni method or the Fisher's least significant difference one. And then there's another one that comes. The name is right on the tip of my tongue, but I can't spit it out. Not really here nor there. The Tukey is great in that it's pretty easy to do. However, it only works for a balanced test, which is a little annoying. Anyway, Q is the value we're going to find, Q. Basically, the Tukey test is a T test. It's based on a T test, okay? So it's based on a T. It's not exactly a T, but it's based on a T. And what you're going to do is you're going to take x bar sub I minus x bar sub j. What does that mean? It means you're going to take the average for Albertsons minus, for instance, the difference from the average from Whole Foods. Okay? And you're going to compare them one at a time. And then you're going to divide out by the square root of MSE over N. What is this? What's going on? Well, let me figure it out for you. MSE is what is called the mean squared error. It is in the chart. It is MS, oh look, also known as error. It is that number right there. Boom. Okay? And what is N? N is the number in each column. So 5 in this case. Okay? And so N is just the number in each one column. So if you look, this denominator is going to be the same for every time we do this business. Okay? So when we do that, keep that in mind as we go along. You'll see what I mean. Now, if I had 3 columns and I wanted to compare 2 at a time, why, that is 3 choose 2. In other words, there are 3 combinations. you're going to test, in this case, Albertsons versus Whole Foods. You're going to test Albertsons versus Winco. And you're going to teach Whole Foods versus Winco. And you're going to test all three of them. But this one, and then this one, and then this one. You're going to do them separately. Okay? Now, if it's me, I just do all this in Excel because it's pretty quick. So I'm going to do equals the square root of, and I'm going to click on this number right there, divided by 5. And that baby's my denominator. Every single time. Yeah, you got to love that. And then I'm just going to start doing it. Now I'm going to probably put in a few labels because that's what I like to do. So Albertsons versus Whole Foods or whatever, right? And I'm going to say equals, parentheses. And I'm going to take this minus that, parentheses, divide by that. Done. And then I'm going to do Albertsons versus Winco. And I'm going to say equals, oops, parentheses, this minus that. Oops, I missed my parentheses. Sorry. What happened? Oh, I pushed the wrong button. Maybe if you pushed the shift instead of the control, you dum-dum. There you go. Divided by, boom. And then what if I do, let's do, who did I miss? Whole Foods versus Winco. Yes? And so here it's going to be equals, parentheses, did it right that time, what do you know, got lucky, minus this dude, divided by this fella. Boom. What? Now, your eyes might be drawn to these two on the outside. Because I said that this was based on a t, and your eyes might go, holy cow, if you got a t of 4.6, that's pretty weird. And if you got a t of 6, that's really weird. And so your eyes might be kind of drawn to that, and for good reason. Okay? Now, in the back of your book, in the appendices, the appendices, I should say, I do speak English. It's crazy. Once in a while, I actually say it right. It is on page. I will tell. Well, that's not true. I have the previous version of the book in my hot little hand today. But I will tell you what page-ish it's on. You're looking for... Oh, for God's sakes. Oh, here it is. Yes. It's in Appendix C, and you're looking for the Tukey test. It's Table N. At least it's Table N in my book. Okay? And so you're looking for the one at the top of the page that has 0.05 on it. That's a big deal. Okay? And so I'm going to pause for a second, see if I can find a picture online for you. Alright, so it looks similar to this one. It's similar. It's not exactly the same in terms of the outlay. But K is the number of treatment groups. We have 3 groups in this case. We had the 3 stores. And then the degrees of freedom. Now, the degrees of freedom is the degrees of freedom for error. So it's 12. That's kind of a big deal, but you've got to know that. And so I'm going to err to 12. I'm going to come over here to 3. And so 3.77, that's my critical value. So if any of these guys are bigger than plus or minus 3.77. Now again, the way to think about this is, yes, it is indeed a two-tailed t-test. So what we're doing here is basically it's a t-test, I should say. It's based on a t. So when you draw this out, what we're saying is negative 3.77 and positive 3.77. If anybody's out here or out here, there is a significant difference between those two. And if it's in the middle, there's no significant difference. So this guy, wow, that's significantly different. So is this one. That's cool. But this one is not. What does that say to me? It says that there's no significant difference between Albertsons and Winco. Now there is between Albertsons and Whole Foods and between Whole Foods and Winco. So what's the bottom line here? Whole Foods, you see, is significantly different than the other two. Is significantly different than the other two. Okay, that's the bottom line. Okay? And that's how we're going to play that game. It's pretty easy to do. Whenever you can, you want to simplify it as much as you can. Yes, you could say Albertsons is different than Whole Foods, and Whole Foods is different than Winco. But they have that common denominator in that they are significant. Whole Foods is significantly different from everybody. Okay, so let's try another. And so, yeah, so blah blah. John feels he wants to test the difference between Miracle Grow and Black Magic and your Walmart brand of potting soil. Okay, I don't know. And so he grows some strawberries or something. He's going to measure how many pounds of strawberries he harvests out of this pot. I don't know. I just work here for now. And as you can see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. This is an unbalanced Anova this time. Okay? So when I do the follow-up to this, if there's need for a follow-up, I will be using not the Tukey, but the Chaffee test. So we'll do a couple of each one. You'll get the hang of it, I promise. It's pretty easy to do. Okay? And then it's just 3, 4, 5, 5. Oops. 7. Boom. Done. Oh, crap. I got an extra line in there somewhere. Darn it! Go away. That's cool. Alright, so 4, 4, 6, and 9er. And then let's drag it over here. So 2, 1, 2, 3, 4, 3. Beautiful. Okay? Now, it's the same exact way of going about it. Exactly the same. Okay? We're just going to go to the data and then data analysis. That part's all the same. Single factor, of course. You have to re-highlight your data because it missed some of it. But what about this blank cells in here? What about them? Just let them go, man. It's okay. And sure. Boom. There it is. Done. Woo, baby. Feast your eyes right there. So what is our decision? Our decision is to reject H0. You're like, Jay, we didn't do an H0. Well, we should have. And so H0, there is no difference in strawberry yield due to potting soil. Due to potting soil. And then at least one is significantly better or different. I shouldn't say better because one could be significantly worse, yes? At least one is significantly different. That makes sense? At least one is significantly different. Now, just eyeballing it, it sure looks like Walmart stinks pretty bad. That's what it looks like to me. But I don't know. Let's find out. Okay? So, there it is. Now remember, how did we find this p-value? We found it by finding the F statistic. How did we find this F statistic? We took this one divided by that one. With how many degrees of freedom? This many and that many. Okay? Now, hey, wait a minute. This sucker is unbalanced. If I'm going to do a Chaffee, I better know how to run a Chaffee test. Now, the Chaffee is based on an F. Now, it's not an F, but it's based on an F. So, what you're going to do is take x bar sub I minus x bar sub j, same scenario as last time, but this time you're going to square the difference. And you're going to divide by MSE, same MSE, same MSE, 1 over N1, I rather, plus 1 over Nj, parentheses, parentheses, parentheses. Okay? Now, in Excel we can do this pretty straightforward. It's not very hard to do. So over here somewhere, again, I would just do like Miracle Grow versus Black Magic. And then I would do Miracle Grow versus Walmart. And then I would do Black Magic versus Walmart. Okay. And here I'd literally just go equals. I'm going to subtract this average minus this average squared divided by parentheses MSE, that's this guy right here, times parentheses 1 divided by, now you can do this any number of ways you want to. You could click on the 6 plus and then 1 divided by and click on the 4, or you could type it in, whatever makes you happier. It makes no difference to me. But there it is. And I'm going to do the same thing here. I'm going to literally do the same thing. So equals parentheses, but I'm going to do this one minus this one this time. Divided by parentheses MSE times parentheses 1 divided by 6 plus 1 divided by 6. This time I typed them in. What? You're crazy, Jay. Well, I know. Whatever. So I feel like between Miracle Grow and Black Magic, I'm not shocked that there's not a lot of difference there. That's kind of what this is looking like right here, right? Holy cow, that's big. Duh. I feel like there's quite a bit of difference here to here. I'm going to bet you that this versus this is going to be pretty big too. So let's find out. I can't stand the surprise anymore. The suspense is killing me, man. MSE times parentheses 1/4 plus 1/6. What? Done. Holy mackerel, that's big. Now, it doesn't really shock me a great deal. Okay? But what I need is I actually need that critical value. How am I going to find it? Okay? Well, I'm here to tell you. And so, let me just find the right page here in my book, and then I'll tell you how to reference it. Alright, so here's the thing. With the Shafei test, we need a critical value. So your book makes a big deal about showing how to find this critical value. Oh, for God's sakes, what just happened? Stop it. Stop it. Stop it. And they call it, well, they call it F prime. And that critical value is K minus 1 times the F with, check it out, guess how many degrees of freedom? Take a wild stab. I mean, you'll never guess in a million years. 2 and 13. See that? So the degrees of freedom will be from the between, comma, the degrees of freedom for the within. Okay? And the idea here being is, well, wait a minute. Don't I already know that? I do. It's right there. It's right there. So that 3.8 is going to go right here. And how many groups did I have this time? I had 3. 3 minus 1 is 2. So 7.6 is my critical value. Are any of those values bigger than 7.6? Yes, this one. So there is a significant difference between Black Magic and Walmart, okay? But there is not a significant difference between the other two, okay? And it's pretty straightforward in that regard, okay? Yeah. And so that's the game. Now, the Shafei test is pretty good. It's pretty easy to do. Okay, so not terribly difficult to follow up on in any way, shape, or form. It's just a matter of doing it. So that's my critical value again. And so what do I do here? Well, for the follow-up, there is a significant difference in yield. What in the Sam Hill? There is a significant difference in yield between Black Magic and Walmart. Now, it doesn't take a rocket surgeon to figure out that Walmart kind of sucks. I think we all saw that right off the get-go. And that Black Magic is the best. Now, the question then boils down to, so don't buy Walmart. That's stupid. So then the question is, do I buy the Black Magic or the Miracle Grow? Now, you're like, wait a minute. Wait a minute. Listen, we already showed that there was no difference between those two. There was literally no difference. There was no significant difference. So if they don't change the yield, what do I base my decision on? The Black Magic wrapper is cooler looking than the Miracle Grow. Okay, I guess that's one way. They don't sell Black Magic in my town. I'd have to drive 20 miles. Then freaking use Miracle Grow. Okay? But I feel like the price of the Miracle Grow is more expensive. Then use the Black Magic. Okay? You're going to have to use some other follow-up if there's no significant difference between the two. Okay? We are interested in which of these does a better job for my strawberry plants. And so the answer to that is, well, Black Magic is better than Walmart. But after that, it doesn't really make any difference. Okay? Now, a couple of things I want to mention here. I will always write MSE because I'm old school and that's what we used to call it back in the day. We've always called it that. We still call it that. But your book refers to it as S squared sub W. That is the variance of the within groups. Okay? And that's great, I guess. I mean, it's fine. You can look at it that way. There's nothing wrong with that. Just to me, I prefer to write MSE. So just be aware of that when you see that happen. Okay, so here's another one. Let's compare. So, yes. Yes, let's do weights of burritos at like 4 different, food carts. Okay? And so, of course, my H naught is always there is no difference. No difference in what? In weight. Due to what? Due to what cart you buy it at. Due to where you buy it. And of course, at least one is significantly different. Bigger or smaller? Different. And so it's cart A, cart B, cart C, cart D. Don't really care. You can give them some cool names if you like, but I don't care. And I'm going to weigh them in, I don't know, grams, I guess. 600, 500, 450, 500. You should fire this person if they can't be more accurate in building a burrito than that. That's pretty lame. Just saying. Not judging. Just saying. Kind of judging. Maybe judging just a little bit. I feel like if you cannot be more precise than that, you don't deserve to work for me. Seriously, look at this. Really? You made one that's twice as big? Are you kidding me right now? What's up with that, yo? Now, clearly there's a lot of variation in this group, and in, well, some degree, quite a bit in this one too. These ones not so much. Okay, there is quite a bit of variation between here and here, yes? Wow, that's quite a bit different. And between here and here, quite a bit. Between here and here, I would say there's very little. Notice that if I'm going to do 4, choose 2, there's going to be 6 comparisons. At the end, I'm going to have to do A versus D. Well, I don't know why I did that one first. A versus C. A versus B. I'm going to have to do B versus C. B versus D. B, B, D, that's nice. And then C versus D. 6 different comparisons. Notice that they are balanced, so this will be a Tukey test when we get done momentarily. Okay? But Jay, what if I used Chaffee? Would it change anything? It would not change anything. Okay? It's a kind of a, well, I don't know about grosser. It's not as nice of a problem, perhaps, if you do it with that, just because it's kind of a little more intriguing denominator, I guess. A little more moving parts in the denominator, although they're the same. So you really have to do it one time, I guess. But I don't know. I'm just more of a fan of, oops, that'd be bad. I'm kind of more of a fan of picking one versus the other. But since this book teaches both, we will use the Tukey for a balanced approach, and we'll use the Chaffee for the unbalanced approach. Again, not a huge deal. They are only two of the many different, what we call post hoc tests. So after the fact, after you've shown that there is in fact a difference, now we want to analyze it further. We call these also pairwise comparisons. Just to be aware of that. Okay? So, there they are. Oops, I don't know why I highlighted them first. Can't do that. Come over here, data analysis. Again, single factor. Highlight your data. Whee! Labels in the first row. Sure, done. Look at that sucker. Wow, there's a difference. I'm shocked. I'm not shocked. Okay, so there it is. So I'm going to reject H naught, which of course means at least one is significantly different. So which one's different, Jay? I don't know. Let's find out. So let's do, I'll just go through them all real quick. So A versus B, A versus C, A versus D, B versus C, B versus D, and C versus D. And there should be 6 of them. 1, 2, 3, 4, 5, 6. Dang, yeah, that's right, bro. Now, I'm going to find that denominator first because, well, that's what I like to do. So it's the square root of MSE divided by 4. And it's 48. Okay, 48 and a half. So what I'm going to do here is I'm going to go, all right, equals, parentheses. It's going to be this minus this divided by this, and then move over, equals this minus this divided by that, equals, if you're playing along at home, you realize that 1 for a t statistic is pretty small. Again, it's kind of a t statistic, so it's not exactly a t, so don't quote me on that, because it's based on a t. But the 4s, they seem pretty big for a t. Okay, just saying. So be aware. And then this guy minus this guy, oops, that guy, divided by this one. 5.6 seems pretty large too. Just saying. Not saying, just saying. It doesn't seem like this one's going to be very big. Oh, it's not very big. Weird. Equals, 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 parentheses. This seems like it's going to be a fairly large difference this time. Weird. Hey, that's crazy. That's just weird. Let's go look at our Tukey table, shall we? So here's our Tukey table. We have 4 now. And let's go back at our table, and our degrees of freedom is 12 again. So 4 and 12 is here, 4.2, 420, blaze it. So 420 is our critical value, that is plus or minus 4.2. So if you are out in the tails from there, we are going to reject. So this guy is a significant difference. Okay? This guy is a significant difference. So is this one. And so is this one. Okay? You'll notice the only ones that aren't significant is that A and C and B and C are not significantly different. That's the best I can do. I mean, I could lay this out a bunch of different ways, but really A and C there's no difference, and B and D there's no difference. Okay, so that's about as good as I can do with the follow-up. So we rejected H naught, which means at least one is significantly different. We already did that. And then on our follow-up, we found that A and C and B and C are no significant difference. Okay, I found that was easier to say the 2 that aren't different than coming back over and saying the 4 that are different. But you could just as easily have said, you could have said, A is significantly different from B and D, and And then I would also then, I guess, say that C is significantly different from B and D as well. You could say that too. Any of those would have worked, right? To me, it's easier if you're babysitting the good kid and you tell him the one thing you don't want him to do versus if you're just dealing with the horrible kid and there's like a million things you tell him not to do. It's easier to say the one thing you're allowed to do. Okay, so whichever is the shorter list, let's go with that. Okay. Now, I'm going to do one more, and I'll do the Chaffee again this time, and we'll see where we go from here. So, I don't know, your early girl tomatoes, and your, I don't know, best boy or big boy. Was it best boy or big boy? I can't remember. And your some other variety. I think it's amazing to me how much better this version of OneNote reads my handwriting than the other one that I use on my Surface. The one on my Surface, every now and again I'll come over here and I'll look and I'm like, it'll literally say the F word and I'm like, well, no, I never wrote anything like the F word over here. But look at this, that can actually read early girl out of that. It's pretty weird. Anyway, so I don't know how many pounds they put on each plant of tomatoes. Notice we're talking about just how many pounds, not whether they're worth eating or not, all right? Because some plants will put on some giant amount of pounds of tomatoes, but they don't taste very good. But they make a lot of them, but does anybody really want to eat them? So again, it's unbalanced Anova. And as always, there is no difference. There's no difference versus the at least one is different. There is no difference. In yield due to variety. And of course, at least one variety is significantly different. Bam. And so, of course, I'm going to bring up Excel, open up my new tab, minimize this sucker a little bit, go that up just a bit, and bring that back up. And let's go to town here. So my early girl, six. No real reason to have to be in order on this particular test, so don't worry about it if you get out of line somewhere and you lose one. Just go back and add it later. 10, 9, 10, 9. Again, completely unbalanced this time. And so we're going to use the Chaffee for a follow-up. So highlight them. Well, I shouldn't highlight them. I always do that. I don't know why. And then single factor, and then go highlight your data. There it is. Hit OK. And look at my p-value. Highly significant. Highly significant. And so now I want to follow up with early girl versus best boy. And then I want to do early girl versus other. And then I want to do best boy versus other. Okay, and so here it's going to be equals parentheses, the average minus the average squared divided by, and then it's parentheses, it's MSE times parentheses 1 divided by 5 plus 1 divided by 4. Done. I would like to point out this time that according to this, there's very little variation within the groups. Each of these groups are pretty similar to one another. Okay? On the previous page, you'll note that that was not true. There's a lot of variation within the groups. We talked about that going in. If you are working at my taco stand and you're making somewhere between a 600 gram and a 450 gram burrito, I'm not happy with you. And between 900 and 500, are you freaking kidding me right now? That's terrible. And that is why this is so much larger. Here, for instance, that's pretty small. That's because these are all relatively similar in each of the groups. Okay? And then here, this is fairly large. That's because there's a lot of variation in the groups. Okay? All right, back to where we were. So E equals parentheses. This one minus this one squared divided by parentheses. This one times parentheses. Oops. 1 divided by 5 plus 1 divided by 4. Oh, what did I do now? Sure. Oh, I need a 1 on there. And then equals parentheses. Let's do this one minus this one. Oops, not that one, you dummy. Sorry, that one minus that one, right? Squared divided by parentheses MSE times 1/4 plus 1/4. Those seem like fairly large numbers, and they are. This one not so much. Now again, to find the critical value for the Scheffé, if you were careful initially, and you used a 0.05, if that's what the problem asked about, this is part of the critical value. So we're going to say it's the number of, we have 3 things here, so 3 minus 1 is 2, times this critical value. So 8.2. Are any of these guys bigger than 8.2? Yes, this one's bigger, and this one's bigger. Okay? So what do they have in common? They both have best boys in common. So if you just want a ton of tomatoes, then you should plant best boys. Best boys are significantly different in yield from early girls and other. Okay? That's the follow-up. That's the takeaway from that. Now, if you are such that you're like, well, I have a Mac, and what am I going to do? I can't run a Mac, da-da-da, blah, 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 da-da-da. Well, you can use Google Sheets. Okay? Now, I don't like Google Sheets as well. I do and I don't. Really, all Google Sheets is it's Excel in the late 90s, basically. But the good news is people have been adding on to this thing recently, and they've been making some really cool add-on features that have brought it up nearly to where it's getting close to being as good as Excel. But you have to go and get them. So once you get into here, if you go to add-ons, you can go down here to get add-ons. And what you want to search for is XL minor, just like that. And this thing pops up, and it'll say free for you. Go ahead and click OK and OK and OK until it says it's done. And then when it's done, it will show up under here, XL Minor Tool Pack, and hit Start. And this thing over here will pop up. Jay, that's literally what the same thing that shows up over here. I know. And so what we're going to do is, for those of you that don't have access to a good version of Excel, you can actually just go ahead and use Google Sheets. So what we're going to do is we're going to do Anova single factor. Now the input range is here. Now this is the only thing that bugs the bejesus out of me about this thing. See, a normal human goes, hey, I want to come in here and click here and then go highlight. Look what it did. It takes wherever I'm clicked. So this is the only thing that's a little weird to get used to in Google Sheets. You want to click here, highlight it first, and then go touch in here. Nice. Now it's grouped by columns. Leave that alone. There are labels in the first row. There's your alpha. Leave it alone there. That's right. Now, for output range, click over here somewhere and then again click into there. And then it'll spit out your Anova table. Oh my gosh, it's literally the same Anova table. Huh? That's crazy. And from here on out, everything's exactly the same. Let's do another one. That was fun. So back over to here, back into here. I know, let's grab this data. Cool. Control C, Control V. Voila. Highlight your data. It's already highlighted, so you should be able to just click in here. It did it. Excellent. And hit OK. And voila. It's the same pivot. It's the same table. And so there you go. Okay, so what I don't want is I don't want a lot of people freaking out because their version of Excel doesn't work, yada yada. It's the same thing. So just, again, go get the add-ons. It's under add-ons. Go to get add-ons. Type in XL minor. Hit enter. And then just install that baby, and it's completely free. Okay? That is what I would do. Okay? If I didn't have Excel, I didn't have the newest version of Excel, if I ran a Mac and I was like, oh, I can't make it work, oh no, it's okay. You can use this thing instead. Okay. Now, some people will want to know, does my TI calculator do Anova? The answer is yes, and I'll show you only on the 89, just kind of sort of how it works. And I say just kind of sort of. I don't want you to use the calculator for this. I just find it's very hard to read. It's kind of annoying. If it's all in Excel, I can just click on things after the fact. To me, that just makes so much more sense. So I'm going to input some data. This is data I'm totally making up, so don't worry about where it's coming from. It's just a different made-up data than the other data I've been doing recently, okay? So there's that, and then, here's some more data. I don't know, whatever. Oh, look, it's unbalanced. Oh, no. Oh, no. All right, cool. Now, I'm going to go to tests. So it's second F6. And Anova is clear at the bottom. There it is, Anova. And then it says, of course, I have data. And so I have 3 lists. Oh, wait, back up a page. It says, how many lists do you have right here? Do you see that? So if I only had, 3, 4, 5, 6, 7, I would input that in there. But I have 3, so that's cool. And here's where it's very annoying. You literally, the first time you do it, you have to type in list 1, 1, and then list 2. Oh, I think I typed the wrong thing. List. Oh, shoot. List. I guess that's right. I can't read that from here. List 2. List. Three. And if you do it right, it'll spit this thing out to you. Which the 89 is actually easier to read, okay, than the 83, 84, but it doesn't make it any better. So what it's giving you is giving you the F and the P value first. So in other words, over here, it's giving you these 2 values here first. Then it's going to give you the between next. Let's go look at it. So there's the between. So there's the degrees of freedom first. And you'll notice this is different data, so of course it doesn't match up. Then there's the sum of squares, SS, and there's the mean squares, the MS, right there. And if you scroll down, it'll give you the degrees of freedom for error down here a ways. So there's the, well, I said it did. Okay, there it is. There it is for the degrees of freedom for error, the mean squares, and the sum of squares, yes? And if you keep going, it also tells you this thing here, which we're not going to use for what we're talking about right now. Okay? You can get it, but it's harder to get at. You just can't click it and stuff. It's not as easy to see. And to be honest with you, I want you to be very comfortable with this thing here, this Anova table. Okay? And if you can't write it down and see it, it's kind of annoying. So you'd have to then write that whole table off your calculator onto a piece of paper so that it looks something like this, and then proceed with the rest of the test. So I really only want you to use Excel with this. To me, that's the way to go. Or Google Sheets, whichever you like to use, or whichever you're capable of using in that case. Okay? Now, I will be doing a follow-up video in terms of where do these numbers come from, Jay? Okay, I will do a short video on that in case you're curious. Okay? I'm not sure that most people are, but by God, I'll do it anyways, just for a good time. Okay? And so once you understand where those come from, these two are easy to see. This is clearly, if I have 4 groups, this is, k minus 1. It's 1 less. This guy here, well, there were 16 total data points, yes? This is n minus 1. This guy here is n minus k. So n, there was 16, and 16 minus 4 is 12. Now, once you have this number and this number, this guy is just this one divided by that one is equal to this guy. And this divided by 3 is equal to that guy. And then the f is this divided by this equals that. And then to get to the p-value, it's literally just a matter of doing the f statistic. So I will run through that whole thing with you in a separate video as to where this thing comes from. But for most of us, and I mean including myself, I really don't care. I just want to know how to run the tool. Okay? So I guess takeaways are this. First of all, our H-naughts and H1s will always be the same. We are always going to be testing 3 or more groups. We're testing to see if there's a difference in their averages, their means. If it's balanced, that's there's an equal number in each column, I'm going to use a Tukey follow-up. And if it's unbalanced, I'm going to use a Chaffee. And don't forget the MSE. MSE is this guy right here. It's the mean square for the within groups, but that means if it's within groups, it's just because there's an error happening there. There's some variation that just happens because things happen. And that's it. So I hope that helps. Oops. Cancel.